Are there any questions?
Francesco is.
Yeah. Are there any questions on this fourth presentation about sonodynamic therapy? Yeah.
Yes. Thank you for the excellent presentation. My name is Stuart Marcus, and I have spent 25 years in the development of photodynamic therapy, especially with ALA. So I wanted to ask a couple of questions of this excellent result. Number one, the term photodynamic specifically implies the transfer of energy from light to molecular oxygen. Of your excellent papers, have any of you data to show that sonodynamic is a term which can be used to imply the transfer of energy from ultrasound to molecular oxygen?
So I think the term sonodynamic therapy implies that we use sound in order to activate these substances, and actually there are several mechanisms by which the substances that we are using is not yet understood.
Do you have any evidence for any mechanism?
No.
Thank you. The next question is,
it's very...
In photodynamic therapy, there is a reciprocal relationship between power and concentration of photosensitizer. Have any of you done studies to show that you can raise the power to get an equivalent cytotoxic effect from a lower energy?
I think no.
Or sorry, from a lower concentration?
Yeah,
Not yet.
I think no. But some data demonstrating the generation of the loss after sonication to the photosensitizer, we have the result, actually.
No.
But a relationship in between the power of sonication and or concentration, we don't have any data.
No. Thank you, but I want to say that despite that, I find this the most exciting finding in glioma research.
Yeah. This is really
Thank
figure out. We have to figure out that kind of things.
Along the same lines of mechanism, potential mechanism. So I noticed that all the things that you're working with are fluorescent dyes or other types of dyes. So is it necessary to have a dye as the intermediary between the ultrasound and energy deposition?
Doesn't have necessarily to be a dye. The fluorescent is a dye. 5LA is a metabolic agents that are different.
No, but it results in something that is a dye, isn't it? ALA.
No.
No?
You mean mechanism of the SDT with 5LA?
Yeah.
You mean? Oh, yes. The SDT with 5LA, the 5LA is accumulated in the mitochondria. And after the sonication, the loss induces mitochondrial membrane potential of loss. And this causes cytokinase C is high uptake and Casper's cleavation, and this causes apoptosis in the tumor. This is a mechanism of SCT.
Okay, thank you.
Okay, Sacha, you are actually right. And the sensor should not always be the dye itself, because the mechanism of the we have it's already published that one of the mechanisms of the STT is just a radical transferring from the it's actually amplifying the radical which is generated by the cavitation. So they will that's the sensor that will just increase the number of radicals by the can say actually the changing its form. So it has nothing to do with the can say PDT. PDT just transfer energy to the dye, but it has nothing to do with that. So Actually, it's a phenomenon related to cavitation, so it has nothing to do with the PDT.
Well, yes, cavitation is one of the proposed mechanisms for sonodynamic therapy as well.
Without cavitation, you cannot do anything. Right.
So how
Well-
essential is iron in the situation here? Because the fact of the matter is you're looking at a Fenton reaction, right? So you in a Haber-Weiss chemistry causing ROS to be developed within the cells. And so one thing you could basically propose is actually loading these tumors with iron, just giving the animal more iron intravenously, and you may get the exact same effect with an intravenous iron injection. So the real question is you want to increase the ROS in the system, and that's one of the things you would want to try to do.
Yeah, that's true. In fact, one of the paper regarding fluorescent with sonodynamic therapy with fluorescent in vitro used fluorescent with more iron bindings, but of course this is not clinically approved, whereas the dye that we are using, the normal fluorescent, which probably achieve a which probably is less effective, is clinically approved. So if we want to move faster to human, I mean, we have a little body of evidence. So,
Excuse me. And this is my opinion. The background of the mechanism of the sonodynamic therapy is just a little bit different from the photodynamic therapy. Of course, the ROS generation is one of the cause because, this is of course. And also, we confirmed another mechanism in previous study using another sonosensitizer. I think there is some other mechanical, for example, the shearing stress or attacking the microbubble oscillation attacks to the cell membrane or something.
Yeah. I just think it's interesting that the comment was just made about iron being very important, and the end product of ALA metabolism in the cell is heme, which contains iron. So you're actually, by giving ALA to the glioma, you are concentrating iron by increasing heme within the cell. I don't know if the iron within the heme would be sonodynamically active, but if you put those two theories together, it might explain the action.
Sure, you're right, I think, yes, I agree with you.
But the sonication effect is cavitation or is hyperthermia?
Can I answer that question?
Yeah, sure.
Thank you. Sure.
In the 1980s, we were challenged to dissolve the gallstones, and we conducted some clinical trial, in fact, in a human. These gallstones were exposed to 220 kilohertz, and monooctanine was injected into the gallbladder. So we dissolved large gallstones in about 8 minutes. So I conducted a study called hyperbaric chamber, where we put the pressure to reduce the cavitation effect. And within that chamber, there was no cavitation. So we cannot dissolve the stones. So it was established well that it is the cavitation effect.
Thank you.
and to add to your question, we did some previous studies with the thermocouple, and we chose the parameter that didn't elicit any thermal rise. So we don't have any thermal rise. I don't know about cavitation, but in the previous experiment we had tissue damage, probably due to cavitation, whereas in our results we didn't have any cavitation, so probably none of the two. Nor thermal rise nor cavitation. But
And there are
I'd like-
all right, go ahead.
I'd like my opinion. In my study, I can't detect the cavitation using the TCMR's FUS device, except neuro. So I think cavitation is not important. The energy or mild hyperthermia is very important for the SDT effect, I think.
Thank you. Thank you very much. Thank the panel very much.